We want to solve by creating a perfect square trinomial and using the square root property. We have 4x squared minus 20x minus 15 equals 0. This isn't the most efficient way to solve this quadratic, but we're trying to practice this idea of creating a perfect square trinomial so that we can apply the square root property. A perfect square trinomial looks like a squared plus 2ab plus b squared, and that factors to quantity a plus b squared. And there could also be a negative middle term, and that would factor to quantity a minus b squared. So when we look at a quadratic, we would think about this perfect square trinomial formula typically if our leading term and our last term are perfect squares. So the first part and the last part here are some a squared and b squared. So really nice perfect squares. So the 4x squared part, that part's nice because we can rewrite that as quantity 2x squared. 4 is a perfect square. But when I look over here, negative 15, that's not one of the nice perfect squares if we take 2 squared, 3 squared, 4 squared, 5 squared, etc. So this doesn't really scream perfect square trinomial, but we can make it work. So this formula says that what we need is a squared, I'm going to look at the bottom one, minus 2ab plus b squared. So right now my a value is 2x. That is my value of a. So this middle term has to be negative 2 times a times some b value. So what I have in negative 20x is I have negative 2, and then I'm going to put times a. We just said a was 2x. And then what I'm going to need is I'm going to need to figure out what the value of b has to be to complete this formula. So in order to create a minus 20x in the middle, I'm going to need a positive 5. So negative 2 times 2x times positive 5. If I multiply all three of those together, I'm going to get negative 20x. So this 2x, again, was the value of a, and basically I had to work for the value of b for a second, right? I had to think about, well, what would b have to be to make the middle term negative 20x? So now the rest of the formula needs to look like plus b squared in order to have this perfect square trinomial. So we just figured out the value of b was 5, so we're going to need plus b squared. So we're going to do plus 5 squared. So we're going to have plus that value of b squared. But we can't just randomly add 5 squared. We also have to subtract 5 squared because we would change the problem if we just randomly added 5 squared. So we have to subtract 5 squared. And I also can't forget about this negative minus 15 at the end, so that's still there as well, equals 0. Whew, so it's a little clever algebra situation we have going on. So if you were to, multiply these out, and we would get the same original equation up here. We've just kind of done it in this really unique way that now creates a perfect square in the first 3 terms. So the first 3 terms are now exactly a squared minus 2ab, where a is 2x and b is 5, plus b squared. So these first 3 terms are going to factor to a minus b, so 2x minus 5, all squared. And then these guys on the outside are just like terms, they're just numbers. So negative 25 minus 15 is going to be minus 40, is equal to 0. So why is this helpful? Well, now I can apply the square root property by just adding the 40 to the other side. So 2x minus 5 squared is equal to 40. And then I can take the square root of both sides. So I'm going to get plus or minus the square root of 40. And then I can add the 5 to the other side. So I have 2x equals 5 plus or minus the square root of 40. And actually, 40 is 4 times 10. And the square root of 4 is 2. So I can rewrite this as 2 times radical 10. Divide both sides by 2. And I end up with x equals 5/2 plus or minus radical 10. So let me just finish off what I did there. So I did 5 divided by 2 here, so that's 5/2. And then 2 rad 10 over 2, the 2 simplify and just give us rad 10. So I have two answers here. And again, this wasn't the most efficient way to solve this quadratic equation, but it was more about the algebra behind remembering and creating this perfect square trinomial so that we could apply the square root property.